Greetings, math students. Today we're going to be going over writing and solving systems using substitution. So if you remember the previous lesson where we mostly graphed systems of equations and found where the graphs crossed, here this is another way we can solve these sorts of systems of equations. And this is actually a very important topic that is going to come up not just here, but repeatedly throughout your math education. So it's something you really want to know, something you really want to get familiar with. In fact, it's something we've been using already throughout this course, but here we're going to kind of give some more formal definitions and formal information about it. Let's go ahead and go to this warm up here. And I want you to take a moment, see if you can solve this puzzle. So this is kind of like a silly puzzle here, but you have 2 volleyballs plus an 8th note equals 12. 3 books plus 2 volleyballs equals 19. 4 8th notes equals 8. And so what's a book plus a volleyball plus an 8th note? Well, this is kind of a silly little puzzle here, but it's easily solvable because what we have here, we could use this. Treat each of these as a variable. So here I've got 4 notes equals 8. So what do each of these notes represent? Well, we're assuming that each of these notes represent the same quantity. So in this case, it would be 2, right? 2 plus 2 plus 2 plus 2 equals 8. So the notes each equal 2. Now that we have that information, we could use substitution to help us. So instead of in this first equation, here we have a volleyball plus a note, the 8th note gives us 12. Well, we now know that this 8th note is actually equal to 2. So now we have a volleyball plus 2 equals 12. So what does that mean each of these volleyballs would have to be? Well, they're each 5, right? Because 5 plus 5 plus 2 is 12. Now that we know the value of the volleyballs, we can replace these 2 volleyballs with 5. So using substitution. Again, we could use substitution to replace a variable with a value that we know that it equals. So in this case, we know the volleyball variable equals 5. So I could replace each of those volleyballs with 5. So here we have a book plus a book plus a book plus 10, essentially, equals 19. So that means each of these books is 3, right? Because 3 plus 3 plus 3 plus 5 is 19. So now we can solve this last one. We know the book is 3, volleyball is 5, 8th note is 2, so this equals 10. Okay. Hope that made sense. Let's go ahead and move on. Go ahead and go to page 11 here. In this activity, you'll write the equation for each line in a system of linear equations given the graph of the system. Then you'll use substitution property to solve the system. Examine the graph on the system of linear equations and then answer the questions that follow. Well, the solution of a system of graphs like this, system of equations, is the intersection of these 2 graphs. So we already know where the solution should be. It's right at this intersection, right, of lines 1 and 2. But you can see that this intersection is not on grid lines, right? So it's not in a convenient spot. You can see that here, right? It's not quite on like 2, 3 or something, right? It's more than 2 on the X, but less than 3. And then on the Y, it's more than 2, less than 3, but it's some fractional amount. So it's hard to solve this one through graphing and find the exact values, but through substitution, it's actually pretty easy. So the first thing we want to do is find the equations of the 2 lines. So let's go ahead and look at line number 1. Remember, to find the equation, we can write it in the form y equals mx plus b, the slope-intercept form. So we need to find the slope and the y-intercept of line 1? Well, the y-intercept is where the line crosses the y-axis. So in this case, our y-intercept is -2. That's the value of our b. So we're going to put -2 here. The b is the y-intercept. So in this case, for line 1, the y-intercept is -2. Now, how do we calculate the slope? Well, remember the slope, or your m, is the rise over run. So rise divided by run. In this case, you'd rise 2, run 1. So 2 over 1, which is just 2. So the equation for line 1 is y equals 2x minus 2. Go ahead and pause the video and see if you can find the equation for line number 2. Okay. Notice for line 2, the y-intercept is 2, positive 2. So that's our b. That's our value of b. Whoop, is 2. And the slope, again, it's the rise over run. So I can look from this y-intercept and rise 1, run 3. So rise 1, run 3. So what would I put here? I would use this fraction bar, rise 1, run 3. So 1/3 is our slope for line 2 and a y-intercept of 2. Okay, so how do we use substitution to solve the system of equations? So what we're going to do is I'm going to write down the 2 equations. So here's one of the equations, and then the other equation was y equals 2x minus 2. Okay, so here are my 2 equations. Now, what I want to do is I want to use substitution to find the solution for the system. Well, what I notice is they both say y equals. See how this one says y equals 2x minus 2? And the other one says y equals 1/3 x plus 2. So since they both say y equals, well, if 2x minus 2 is y, and 1/3 x plus 2 is also y, that means we could put these equal to each other because they both equal y. So we can write our equation putting them equal to each other. Essentially what I'm doing in this first equation, it says y equals 2x minus 2. I'm taking this value of y, right, because y equals this, and I'm replacing this y with what y equals. Hopefully that sort of makes sense. I'm replacing this y in the second equation with the value of y from the first equation using substitution. So how would I rewrite this equation then? Well, now we can write it as 2x minus 2 equals 1/3 x plus 2. Now, if you're like me, you're not a fan of fractions, so we can go ahead and get rid of this fraction by multiplying by the denominator. So in this case, I'm going to multiply everything by 3 because that's the denominator in this fraction. We're going to multiply every term in this equation by 3 to get rid of this denominator here. So the 3 gets distributed to everything on both sides of the equation. So this becomes 6x minus 6 equals, now what happens when you multiply a whole number times a fraction? Remember, you multiply times the top, then divide by the bottom. So 3 times 1 is 3. 3 divided by 3 is 1. So that's just 1x. I could just write it as x. And then plus 6. Now this equation looks much easier to deal with because we don't have any fractions. What I can do now is subtract x on both sides of the equation, giving me that 5x minus 6 equals, and then on the right side, we just have a 6. Add 6 to both sides of the equation to cancel this 6 here, giving us that 5x is 12. Lastly, to get x by itself, we're going to divide by 5. I hope you're following along and writing down everything I write. This will make it a lot clearer what's happening. So x in this case is 12/5. So this is the value of x, right? We wouldn't be able to tell that from the graph, right? Because this is like not a nice even integer, right? It's a fractional number, which kind of a pain to see on the graph exactly where it's at. But with substitution, we can get the value, the exact value, which is nice. Now we know the value of x. Can we find the value of y? Well, yes, we can, because now that we know the value of x is 12/5, I can replace this into either one of the original equations. I'm going to plug it into this one. So I'm replacing x with the value of x that we found earlier. So replacing the x here with the value of x that we found. So now this equation would say y equals 2 times x, and the value of x is 12/5. And then minus 2. Again, just replacing the x with the value of x that we found. So this gives us y equals, now how do we multiply a whole number times a fraction? Well, normally we would multiply times the top, divide by the bottom. In this case, it doesn't divide evenly, so we'll just multiply by the top and keep the denominator as is. So 2 times 12 is 24. So we can call this 24/5. And then we still have a minus 2. Okay, hopefully you're strong with your fractions. I could think of this 2 as 2/1. And when we add or subtract fractions, we need to have something in common. Hopefully you remember, we need to have a common denominator. So when we're adding or subtracting fractions, we need a common denominator. Now in this case, here the denominators, they don't match. Here we have a 5, and then here we have a 1. So how can I change this second fraction so that it has a denominator of 5? Well, I can multiply both denominator and numerator by 5, and that'll change this first fraction doesn't need to change, but the second fraction now will have a denominator of 5. So remember, whenever we're adding or subtracting fractions, you'll have to change the fractions sometimes so that they have the same denominator. And now that they have the same denominator, we can easily subtract the numerators, giving us 14/5. Well, there you go. So the x coordinate is 12/5. We found that earlier from here. And then the y coordinate, because this is y equals, is 14/5. There you go. 12/5 and 14/5. Okay. Hope that made sense. If you have any questions, comment them below. Okay. We can move along all the way to page number 19. Now, here we have a more advanced puzzle. It's similar to the puzzle we had at the very beginning, but this time it's just piles of books and eighth notes. We don't have the volleyballs. So how do we solve something like this? Well, we can think of each pile of books as a variable, and we could think of the eighth notes as a separate variable. So how would we solve something like this? Well, let's think of our piles of books as our x values. So this is like x plus x plus x. And then we could think of these notes as y's. So this would be like y plus y. Similarly, what would this second equation look like? Well, it'd look like x plus y plus y plus y equals 25. So let's go ahead and combine like terms on this first equation. So this would be 3x plus 2y, 3x plus 2y equals 33. Meanwhile, what would the second equation look like? Well, hopefully you could see that that would be x, a single x, plus 3y is 25, or equals 25. Now, how are we going to use substitution to help us solve this equation? Well, one thing we could look at is, let's think back to our previous example we did. Remember, they both said y equals. So we had a variable by itself, right? We had y all by itself in the previous example. Well, this example, we don't have a variable all by itself. We don't have something that says x equals or y equals. Instead, we have x and y together for both equations, right? So when we want to use substitution, the first thing you should look for is, can I get one of my variables alone easily? So in this case, yes, I can get the x alone in the second equation. So in this equation, getting x by itself is the easiest way to get a variable by itself in this system. So what we're going to do is we're going to get x by itself here. So in other words, we're going to solve for x. And the way we're going to do that is subtracting 3y on both sides of the equation, giving us that x equals negative 3y, we'll say, plus 25. Okay, hopefully you can see how we got this blue equation changed to this black equation. Okay, it's the same, it's really the same thing. Now that we see that it says x equals, and then we have this expression, x equals negative 3y plus 25, we can grab what x equals and substitute it in for the value of x in the first equation. So we use the second equation and then plug it into the first equation. Sometimes you'll take the first equation, plug it into the second. It just depends on what variable you're able to get by itself. In this case, we were able to get x by itself in the second equation, so then we'll place it back into the first equation. Okay, so how would I rewrite this equation substituting the x for the value of x? So in this case, that would be 3 times the value of x. So what's the value of x? Negative 3y plus 25. And then we also have a plus 2y. And then it still says equals 33. Okay? Hopefully that makes sense. Now, if we want to solve for y in this equation, what do you suppose we would do next? Well, hopefully you can see I would distribute this 3 into this parentheses here, giving us negative 3y plus 3 times 25 is 75. And then we also have a plus 2y, and it still says equals 33. Can we combine any like terms there on the left? Well, yes, we can combine this negative 9y and this positive 2y. Those add together to give us negative 7y. We still have a plus 75 here on the left, equals 33. Let's go ahead and finish up. Let's continue solving for y. The next thing I would do is subtract 75 on both sides of the equation. By the way, I hope you're writing this all down. It'll make a lot more sense if you follow along and write down everything I write. Even if you don't fully understand everything, that's okay. Writing it down will help you gain understanding. Okay, 33 minus 75. Well, that's going to be negative 42. Lastly, to solve for y, divide both sides by negative 7, getting y by itself here. That'll show us that y is 6. Now we know what y is. Y is 6. In other words, the value of the music note in these equations is 6. Now that we know the value of y, we can substitute it back in to one of the original equations to help us find x. You could use either equation, but I'm going to plug it right here. And the reason why is because it already has x by itself. That's going to make my life simpler. So this gives us that x equals, and I'm going to write -3y, but I'm going to substitute y with the value of y, in this case 6, plus 25. Now we could easily solve for x here. -3 times 6, negative times positive is negative, so that's -18, plus 25. Here, what is -18 plus 25? Well, that's 7, positive 7, because you have more positives in this case. So x is 7, so the pile of books is a 7, and each of the music notes is a 6. And you could check to see it's true, right? I could see that 7 plus 6 plus 6 plus 6. Well, that does give me 25, doesn't it? You could check. Similarly, in the top equation, it also works. If I know that my x's are 7, 7 plus 7 plus 7, 3 piles of books, plus 6 plus 6, well, that'll give me 33 as well. Okay, so we know that it works on both equations, so we know for sure that we got the correct answer. So that's always a way you can double check, is take your variables that you found, plug them back into the equations, and you should end up with a true statement. In this case, 33 equals 33, and also 25 equals 25. Should be a true statement on both equations. That's how we know it's the correct solution. Okay. So let's go ahead and move along. And let's go ahead and move on to the practice. Now for the practice, just you're going to be offered 5 questions. Please do all 5 and follow along. But I also ask you to follow along with me. I'm going to go over 10 questions. You're going to be given 5 of these questions. But if you follow along with all 10, and I hope that you do, it'll make a lot more sense for you, and it'll make this topic stand out in your mind a little bit better. So let's go ahead and take a look at question 1 here. Maya is signing her daughter up for summer activities. Some of the activities cost $10 and some of them cost $20. Maya pays a total of $130 for 9 activities. How many of each activity did she sign her daughter up for? Okay, so first thing we want to do is create a system of equations. So in this case, some activities cost $10. So the $10 activities, we're going to call these X. Meanwhile, the $20 activities we'll call Y. Now it says that Maya pays a total of $130 for 9 activities. So if I take the number of $10 activities plus the number of $20 activities, that'll be a total of 9 activities. So this first equation has to do with quantity. How many, right? How many? 9 activities. So I take $10 activities, however many that is, plus however many $20 activities. We know that there'll be 9 activities. Now the second equation has to do with the value of these activities, or in this case, the costs of them, right? So each of these $10 activities, they each cost $10. So $10 times the number of $10 activities. Plus, what do you think I'm going to put here? 20y, right? Because each of these activities costs 20. And what do you think I'm going to put here? Well, the total cost. So in this case, that's 130. So here's our system of equations. Now, you could always graph these equations on Desmos or any other graphing calculator and see where they intersect, and that would be your answer. But let's go ahead and practice substitution. So what I'm going to look for is, I'm looking in these equations and I'm looking for, is there a variable that's easily solved for? In this case, there's no variable already solved for. That's the first thing I'd usually look for. Like, does it say x equals something or y equals something? In this case, it doesn't, right? So I'd have to solve for a variable in one of these equations. What I'm looking at now is I'm going to look at this top equation. I could easily solve for x or y in this equation. I'm going to go ahead and solve for x. But if you choose to solve for y, you'd get the same solution. It just would be a slightly different substitution. So what I'm going to do is in this top equation, I'm going to go subtract y. That cancels our y's here. And then this equation ends up being x equals 9 minus y. Okay, because I subtracted y here, 9 minus y. I can't combine those because they're not like terms. Now what we have here is we have x equals 9 minus y. Now what I'm going to do is substitute this in for x here, right? Because x is 9 minus y, so I could replace this x with 9 minus y. So let's go and rewrite this second equation using substitution. So it's going to be 10 times x, and what's the value of x? 9 minus y plus 20y is 130. Let's go ahead and distribute the 10 here into this parentheses. 10 times 9 is 90. 10 times negative y is negative 10y. We still have a plus 20y. By the way, I hope you're writing this all down. Writing it down is a great way to gain understanding. Even if you don't fully understand it now, just copy everything I do and I promise it'll make more sense. Now, can I combine anything here on this left side? Well, yeah, we can combine this negative 10y with this positive 20y. Those combine to give you 10y, don't they? Ooh, I didn't mean to delete that. So negative 10y plus 20y, well, it'll be 90 plus 10y. Now we're going to go ahead and solve for y. So I want to get y by itself. So what would be my first step to solve for y? Well, in this case, I would subtract 90 on both sides of the equation, giving us that 10y is 40. What would be my next step to finish solving for y? Well, I would divide by 10 on both sides of the equation, canceling the 10 here on the left, giving us that y is 4. So we know the value of y now. That was the number of $20 activities, is 4. Now that we know the value of y, I can take that value and replace it into the y right here. So this would say x equals 9 minus y becomes x equals 9 minus 4. Because y is 4. So let's go and rewrite that. That's x equals 9 minus 4, telling us that x is 5. And there you go. There you go. Okay. Next one. We have a system of equations here. 3y minus 2x equals negative 9. Then our second equation is actually nice for us for substitution. Notice it says y equals negative 2x plus 5. So in this second equation is actually nice because it already has y by itself. Whenever we're using substitution, we want to see a variable by itself. In this first example, we had to solve for x, get x by itself, in order to have a variable by itself. But in this one, we already have y by itself, so that's good. That makes substitution a little bit easier for us. So what we're going to do is we're going to take this y equals negative 2x plus 5, and I'm going to substitute it in for the value of y here. So this becomes 3 times y becomes 3 times negative 2x plus 5, because that is what y is. So let's go and rewrite this top equation. 3 times y, which y is negative 2x plus 5. Then we have minus 2x, and equals still -9. So I'm just rewriting this first equation, just substituting the y for the value of y. What do I do next? Well, hopefully you see that I would distribute this 3 here, multiplying the 3 times everything in the parentheses, giving us -6x plus 15. We still have a -2x in this case, still a -9 here on the right. Can we combine anything together on the left side? Well, yes, we can combine this -6x and the -2x, giving us -8x plus 15 equals -9. Now, my goal here is to solve for x. I want to figure out what x is. So what would be my next step to help me solve for x? Well, hopefully you would see I would subtract 15 on both sides of the equation. Remember, whatever you do on one side of the equation, you have to do the exact same thing on the other side. So -9 minus 15 gives me -24. What would be my next step to help me solve for x? Well, I would divide both sides by -8, giving us that x is, what's 24 divided by 8? 3. Okay. A negative over a negative is positive. So now we know the value of x is 3. The value of x is 3. Now, how do we find the value of y? Well, again, we're going to use substitution. So I could take this value for x that we just found, and I can substitute it into this equation here, replacing the x in this equation with the value of x, 3. So let's go and rewrite this equation. It'll be y equals -2 times x becomes -2 times 3 plus 5. What's -2 times 3? Well, that's -6. So y is -6 plus 5. We can do -6 plus 5, giving us that y equals -1. In this case, when we add those, it's negative because we have more negatives. So now we have our y value. You could always check to make sure it's true by plugging into the original equation, replace both the original equations, replacing x with 3 and y with -1, and you should see that both produce a true statement. Let's move on to the next one. Identify the system of equations given in the graph below. Here we have these 2 lines, a blue line and a red line. Well, what do we notice about them? Well, the first thing I notice is that they are parallel. So parallel lines, well, they don't cross each other. So there actually won't be a solution for this system of equations. We covered this in the last lesson. So in parallel lines, that means they have the same slope, and it also means that their system has no solution because they don't cross each other. So these are parallel lines. Now, I don't even need to figure out these equations because when I take a look at these answer choices, I could just look at the slopes. Remember, parallel lines always have the same slope. So in this first answer choice, notice the slope of the first line is 2 and the slope of the second line is -2. Are those the same? Well, no, they're not. What about for this? Do these have the same slope? Well, once again, they do not. Do these have the same slope? Nope. Do these have the same slope? Yes, they both have a slope of 2. So these 2 equations would definitely produce parallel lines. None of these other answer choices would produce parallel lines. Alrighty, question 4. Jim is filling 2 pools at the community center. The first pool already contains 20 gallons of water and is being filled at a rate of 5 gallons per minute. So we're going to go and stop right there, and we're going to write an equation for filling up this first pool. So this first pool, the amount of water in it, we'll call that y. It starts with 20 gallons. So that's our y-intercept, our starting amount. And then it's being filled at a rate of 5 gallons per minute. So 5 times the number of minutes. So the number of minutes is, we're going to call that x. And the amount of the gallons of water we'll call y. Okay, so this is our equation. The gallons of water is 5 times the number of minutes, plus it already starts with 20 gallons. Okay, so that's our first equation. Let's go ahead and figure out the second equation in the system. The second pool already contains 50 gallons, okay, and is being filled at a rate of 3 gallons per minute. So this second equation would be y equals, here we're filling up at 3 gallons per minute, and the starting amount of gallons is 50. Okay, great. We have our system of equations. One thing we could do is we could graph these two equations and just see where they cross, and that would be our solution. However, let's go ahead and use substitution to solve this. The thing I like about this system is that they both say y equals, right? So since they already both have y by themselves, then it's easy to implement substitution. So y equals 5x plus 20. I can go ahead and replace the y in the second equation with what y equals from the first equation. Now I can rewrite this second equation. I'm going to replace y with 5x plus 20. So 5x plus 20 equals 3x plus 50. Now my goal here is to solve for x. So one thing I notice about this equation now when I want to solve for x is there's x's on both sides of the equation. Generally, I don't like that. I like to move all my x's together on the same side. So I'm going to go ahead and subtract 3x here and then subtract 3x here. This way I won't have any more x's on the right. I will only have x's on the left. So that's good. 5x minus 3x, 2x. So we have 2x. There's still a plus 20 over here. Equals, and then 50 on the right. Now let's go ahead and solve for x. So what would be my next step to solve for x? Hopefully you'd see I could subtract 20 on both sides of the equation. Generally, we get rid of whatever's adding or subtracting first. That'll leave us with 2x on the left is 30. 2x is 30. Let's go ahead and finish solving for x by dividing by 2 on both sides of the equation, giving us that x, or the number of minutes in this case, is 15. 15 minutes. Remember, x was the number of minutes, right? To solve the system of equations using substitution, what could be substituted in place for x in the second equation? So here they're asking, hey, I want to replace the x here, or substitute the x here. How would I do that? Well, one thing you could do is we want to solve for x in the first equation. So we want to solve for x in the first equation. That's what they're basically asking us to do, okay? Because it says what can be substituted for x in the second equation. Well, you'd have to solve for x in the first equation in order to substitute into the second equation. So how do we solve for x in this equation? So I'm just going to go ahead and write it to the side. This is the first equation. How would I solve for x here? I want to get x by itself. Well, hopefully you can see I would subtract 2y on both sides of the equation, giving us that x equals 11 minus 2y. If you write that as negative 2y plus 11, that's fine as well. But that's that. Easy. This one looks like where we have to write our system. Let's go ahead and find the system of equations that describes this scenario. A ski rental store rents a pair of skis for $44 a day and a snowboard for $58 per day. Okay. Yesterday, the store made a total of $2,232 on ski and snowboard rentals. They rented 9 more pairs of skis than snowboards. Write a system of equations that can be used to represent this situation and to find the number of ski rentals and snowboard rentals. Okay, so here they're just asking us to write the system. The number of ski rentals, that's going to be our x. So ski rentals, that's going to be x. Can you guess what y is going to be? Well, that's the snowboard rentals. Okay, so notice that each pair of skis that they rent out is $44. So they get $44 times the number of ski rentals. plus, what do you think I'm going to write here? Well, they get $58 for each snowboard rental equals. Now, this will tell us the total amount of money they bring in, right? Because they bring in $44 times the number of ski rentals plus $58 times the number of snowboard rentals. That gives us the total amount of money that they bring in, the total revenue for the day. In this case, the revenue was $2,232. Now, the other piece of information is how we're going to find our second equation. It says they rented 9 more pairs of skis than snowboards. So they rented more skis than snowboards. So if we take the number of ski rentals, they rented 9 more pairs of skis than snowboards. These are not equal, right? That the number of ski rentals is not equal to the number of snowboard rentals because it says they rented 9 more pairs of skis. So I'd have to add 9 to the snowboard rentals to equal the amount of ski rentals. There you go. That ain't right. That ain't right. Which one is it? Well, all of them have the correct first equation, but which of these should be the correct second equation? Well, none of them completely match what we have, do they? But one thing, I wrote my equation like this, but another way we could write that is that if I take the number of ski rentals and subtract 9, that'll give me the number of snowboard rentals. So there might be more than one way to write a proper equation, but the thing to keep in mind is that these two equations are actually the same, because I can go from this equation and create the second one, right? I can, in this case, subtract 9 on both sides of the equation to get this new equation, right? So in this case, here's what they're looking for. Okay. A little bit tricky, but just keep in mind that there might be more than one way to write the correct equation, right? Okay. All right. Question 7. Identify the system of linear equations from the tables of the values given below. So in order to find the equation, remember, we're going to write these equations in slope-intercept form. Slope-intercept form. Now, what is slope-intercept form? Hopefully you're familiar with it. It's y equals mx plus b, where m is the slope of the line and b is the y-intercept. So how do we find the slope and y-intercept of these tables? So each of these are going to have their own equation. So we're going to have 2 different equations here. Well, the first thing I want to find is my y-intercept. Keep in mind that your y-intercept is wherever your line crosses the y-axis. Shouldn't draw it there. Wherever your line crosses the y-axis. So if your line crosses the y-axis here, that's your value of b. Okay. Now, what is this coordinate point? Well, it's always 0, comma, and then whatever your b is. Okay. So 0, comma, b, because the x coordinate must be 0 in order to be on the y-axis. So our y-intercept is always 0, comma, something. Well, that tells us our y-intercept for both equations. The y-intercept for this equation is 5, and the y-intercept for this equation is -3. So for this equation, we know it's going to be y equals mx plus b, our value of b is 5. Similarly, what would this one look like? Y equals mx minus 3. Now we just need to find the slope. Now, in order to find the slope, then remember that's the rise over run. the rise over run. So how can we find the slope? Well, what you can do is use any 2 points that they give you and calculate the rise, calculate the run. Well, how do we calculate? Let me just, I guess I'll just use these 2 points for this one. And you could use any 2 points from this, by the way. How do I calculate the rise? Well, to calculate the rise, you look at the y coordinates. So to calculate the rise, you look at the y coordinates. To calculate the run, you look at the x coordinates. To figure out the rise, you just subtract the y values. So in this case, we'll do 0 minus 3. That's the rise. So we're finding our slope. That's the rise. How do we figure out the run? Subtract the x values. 5 minus 2 in this case. So what does that give us? Negative 3 over positive 3, which is negative 1. So the slope for this line is negative 1. So our equation, now we know the equation for this line. It's y equals, what's our m? Negative 1, x plus 5. They might not put the negative 1 there. They might just put negative x instead of negative 1x. They usually put just negative x because the 1 multiplied by x, the 1 doesn't do anything there. When you multiply by 1, it doesn't do anything. Okay. Similarly, let's go ahead and find the slope for, and again, you could choose any 2 points. They don't even have to be next to each other. Any 2 points from this to find our slope. We want to find the rise over run. So let's go ahead and find the slope here. The rise, we subtract the y values, so 0 minus 2. And then the run, we'll subtract the x values, so 3 minus 5. That gives us negative 2 over negative 2. A negative over a negative is positive. Just like a negative times a negative, it's positive. 2 divided by 2 is 1. So our slope here is 1. Well, that gives us our equation. Y equals 1x. Well, we don't need the 1 there. Just put x minus 3. There we go. There it is. Solve the system of equations given below. X plus 2y equals negative 4. 2x plus 3y equals 1. Well, what I would want to do is solve for a variable in one of these equations. So I want to get a variable by itself in one of these equations. Well, what's the simplest way to do that in this case? Well, what I would say is in this first equation, x is almost by itself. We just need to get rid of this plus 2y, don't we? So how do we get rid of this plus 2y? Well, we could subtract 2y on both sides of the equation, giving us that x equals negative 2y minus 4. Great. So now we have x by itself. What we want to do is take this value for x, or take this expression for x, and substitute it into the other equation. So I'm going to substitute it for x in the second equation. So instead of 2 times x, it becomes 2 times negative 2y minus 4. Replacing x with the value of x. So 2 times x, well, that's negative 2y minus 4. We still have a plus 3y in that equation, and it still says equals 1. What would be my next step here? Well, hopefully you would see I can distribute the 2 into this parentheses, multiplying that 2 times each of the terms in the parentheses. So that's negative 4y minus 8. We also have a plus 3y here equals 1. Can we combine anything together? Combine like terms here on the left? Well, yeah, we can combine this negative 4y, positive 3y. So that gives us negative 1y. We still have a minus 8 equals, and then we have a 1 on the right. Let's go ahead and add 8 to help us solve for y. We're going to add 8 both sides, giving us negative 1y equals 1 plus 8 is 9. Lastly, to solve for y, we're going to go ahead and divide by -1 on both sides of the equation. Divide by -1, divide by -1, giving us that y is -9. Okay, so now we know our y value is -9. Well, that means it has to be this one, doesn't it? Right. This is the only one that has a y value of -9. But if you want to solve for x, it'd be pretty easy. You just take this value of y, -9, and replace it into this equation, replacing or substituting the y with -9, giving us that x equals -2 times -9 minus 4. That gives us that x equals, so let's go ahead and multiply the -2 times -9, giving us that x is positive 18 minus 4, which gives us that x is 14. See that there? Okay, great. Question 9. Identify the system of equations given the graph below. So here we just want to find the equation for each of these lines. So let's first, I guess we could work on the blue line first. I guess I should switch to blue. This would be y equals, and remember, we want to put the equations in the slope-intercept form. That's y equals mx plus b, where m is the slope, b is the y-intercept. So what's our b in this case? Well, it's the y-intercept. So in this case, our b is 5. You can see that there. So we know it's going to be y equals mx plus b. Our b is 5. Now, what's the slope in this case? Well, to calculate the slope, you just do the rise over run. So how do we do that? I can go from this y-intercept to this point here, let's say, and we'd rise 1, 2, and run 1. So up 2 over 1. 2 over 1, which is just 2. So y equals 2x plus 5. That's the equation for the blue line. Well, what about for the red line? Well, again, we want to write it in this form, y equals mx plus b. Let's go and find the y-intercept, the value of b. Here we can see the value of b is -2. That's our y-intercept. So that's going to be y equals mx plus b. Our b is -2, so we'll just put -2. Now, what's the slope in this case? Well, hopefully you can see that this red line is going down as you go from left to right. So this one actually has a negative slope. That's one thing to keep in mind. Here I can go from our y-intercept to this point here. It doesn't have to be that point, by the way. You could choose another point, but it's easy to pick a point that's on the grid lines. You can see that these grid lines, this point right here, it's easy to count to, right? So I'm going down 2 over 1. Down 2, so our rise is -2 over 1, which is just -2, right? Anything over 1 is just self. So our slope is -2, and we have an x minus 2. So there we go. Last question on the practice. The health club offers a silver membership and a gold membership. The table contains information about the one-time registration fee and monthly fee for each membership. Okay, so we can see going to this information here that the silver membership has a 0, you don't have to pay any registration, right? 0 registration fee, but it still has a monthly fee of $87. The gold membership has a registration fee of $468, so you have to pay that up front. But the monthly fee is less. You see that? Monthly fee of $48. In which of the following number of months would the gold membership be a better value than the silver membership? Okay. So let's look at the silver membership. So the total cost, we're going to have y be the total cost. The total cost of the silver membership is $87 times the number of months. So X is going to be the number of months. Y is going to be the total cost. So what about for the second equation? Well, for the second equation, it costs how much per month? $48 per month. So 48X, where X is the number of months, plus there's an upfront fee, right? So a y-intercept of 468. It's like a starting amount. The y-intercept is oftentimes the starting amount. Okay. So now that we have our system of equations, notice that this first equation already says y equals. It says y equals 87x. So I could replace the y right here with the what y equals, substituting that into this. So let's go ahead and rewrite this second equation, giving us 87x equals 48x plus 468. What would I do next? Well, here I've got x's on both sides of the equations. I don't like that, so I'm going to go ahead and subtract 48x. Giving us that we still have 468 there on the right side. What's 87 minus 48? $39x. Now to solve for x, we're going to go ahead and divide both sides by 39. Giving us the value of x is, let's see, 468 divided by 39, using my calculator. In which of the following number of months would the gold membership be a better value than the silver membership? Well, at 12, this gives us 12 here, which tells us that they would be the same value after 12 months. Okay, it'd be the same value after 12 months. So when would the gold membership be better? Well, if you're going to stick around for 13 months or more, then you would save money by choosing the gold membership. Okay, now we're going to move on to the mastery test. Please follow along. You're going to be given 5 questions from this set of questions. I've got 20 questions here. I don't know which questions you're going to be given, so you're going to be given a sample of these 20 questions. But if you follow along with all the questions, it'll give you a fuller understanding, and I guarantee that if you follow along, write everything down, it'll make a lot more sense for you. Okay. Also, if you would like to say thank you for all this hard work of filming all this and all that, just subscribe. That's it. Subscribe, or better yet, share it with someone else. I'd be happy to help them as well. Here in this question, we're dragging the tiles. Okay, so here, well, one thing I want to look at is here I've got these values. It says x equals 2, y equals 7. 5, 2. Okay. Well, this one's going to be kind of a pain because there's a lot to solve here. But let's go ahead and I'm going to do a couple with you and then ask you to do the rest on your own. This one is a simple one. Let's go ahead and do that first. Notice in this second equation, it says x equals 9 minus 2y. So that means I could replace x in the first equation with 9 minus 2y, giving us 2 times 9 minus 2y plus y is 12. We can distribute the 2 over here on the left, giving us 18 minus 4y. We also have a plus y here equals 12. What can we combine there on the left? Well, we can combine this negative 4y and this positive y. So that gives us 18. The positive y is like positive 1y. Minus 3y, when you combine these, equals 12. Go ahead and subtract 18 on both sides of the equation. Giving us negative 3y is negative 6. Lastly, to solve for y here, we're going to divide both sides by negative 3. Giving us the y value is 2. Okay, so maybe it's this one. I don't know. Not all the tiles will be used, so that's one thing to keep in mind. What we can do now is plug this value of y into this right here. So this will be 9 minus 2 times 2. So I'm going to go ahead and rewrite that. X equals 9 minus 2 and replace the y with 2. Replacing this y with the value of y. Giving us that x equals 9 minus 4, which is 5. Okay, so this one does go right here. Okay, because the x value is 5, the y value is 2. I'll help you with one more. I'm going to help you with this next one here to the right of that one. Notice, and this one's a little bit harder, I would say, because it doesn't have any variables solved already, right? There's no variable already by itself. So what we're going to have to do is solve for x in this top equation. So the way I'm going to do that is subtracting 2y on both sides of the equation here, giving us that this top equation can now be written as x equals negative 2y plus 9. Now what we could do is we could take that value that we just found for x and substitute it into the bottom equation for x. So let's go ahead and rewrite this bottom equation. Is going to become 2 times negative 2y plus 9 plus 4y, and it still says equals 20. What do you think we do next? Well, I would distribute this 2 here, giving us negative 4y plus 18 plus 4y equals 20. Something weird happens here. Notice that the negative 4y and this positive 4y, you can combine those together to get 0y. And then we get 18 equals 20. Well, that's weird. That's not true at all, is it? 18 doesn't equal 20. So what does that mean? Well, that means that these two lines are actually parallel. So these ones have no solution. So if you ever solve a system of equations and you get something plainly not true, like here, 18 equals 20, well, that's not true, is it? So that means that the system, they don't cross each other. In other words, that these two lines, in this case, are parallel. They don't cross each other. So that's one thing to keep a lookout for. And so this tile will not be going into any of these. Okay. Another strategy for solving these is simply to graph the system using Desmos, DESMOS.com, and use their graphing calculator. And you could just simply graph the equations and see where the system where the two lines cross each other. Okay, next question. Type the correct answer in the box. Okay, solve the given equation. So we want to use substitution to solve for x and y here. Well, I notice here that this first equation is not solved for either x or y. So I would like to get one of my variables by itself. So my first step here, I can get y by itself by dividing by 2 here on this first equation. I would divide everything by 2 there, giving us y equals, I can call this negative 1/2 x. I kind of like writing it like that, plus 9 over 2. Now you could write this as a decimal, but I think as a fraction, I prefer to work with fractions, at least when I'm doing algebra. If I was doing like statistics, then I usually like working with decimals. Okay, so here it says y equals yada yada, which means I can substitute this in for y in my second equation. Now I know there's fractions here, and that's perhaps a little bit scary, but fortunately, our fractions disappear once we work this out a little bit, and I'll show you what I mean. So don't be alarmed, just follow along. So I have equals -15 here. So what would be my next step here? Well, hopefully you can see that I can distribute this -6 into this parentheses. Well, the 3x doesn't change, but when I multiply this -6 times -1/2, that's going to be a positive now because negative times negative. But remember, to multiply a whole number times a fraction, you multiply times the top, then divide by the bottom. So 6 times 1 is 6, then divided by 2, which is 3. So that's going to be 3x. -6 times 9/2, a negative times positive is now negative. So we'd multiply times the top, then divide by the bottom. So 6 times 9 is 54. 54 divided by 2 is 27. So that's -27. We still have a -15 here on the right. Now what we're going to do, we're going to go ahead and combine these 3 x's. So that's going to be 6x minus 27 equals -15. What would I do now to help me solve for x? Well, I hope you can see that we should add 27 both sides of the equation. I'm running out of space here. So that'll give us 6x is -15. Oh, I wrote 2y. That should say 27. -15 plus 27 is +12, because we have more positives here. Then divide both sides by 6 to get x by itself. Giving us the value of x is 2. So now we know the value of x. How do we find the value of y? Well, what you can do is replace x into this equation, substituting x for 2 in this case. How would that look? I'm going to go ahead and write it over here. So that'll be y equals, and it's going to be -1/2 times the x is 2, plus 9/2. So when you multiply here, normally I would say, oh, multiply times top, divide by the bottom. Well, here I actually want to keep it as a fraction, so we're just going to multiply times the top. So what would that look like? That's going to be y equals -2/2 plus 9/2. Here, my fractions, they have the same denominator, so that makes them easy to add together. You just add the numerators. So -2 plus 9 is 7. So 7/2. Here they want you to write it as a fraction, so 7/2, just like that. Okay, question 3. The software company is throwing a dinner party for its employees at a hotel. Mr. Spencer recorded the prices for 2 different catering companies in the table below. So we have 2 different catering companies here. We have Fantastic Catering and Devoted Catering. Let's go ahead and write an equation for each of them. So for Fantastic Catering, it has an initial payment of $135. Now, I've talked about this before, but if they give you a starting amount, that's usually your y-intercept. So in this case, that's going to be y equals, and we're going to write our equations in y equals mx plus b slope-intercept form, right? Where m is the slope, b is the y-intercept. Remember, this is the way that we write lines most often. So y equals, I know it's going to be plus 135. That's our y-intercept. That's our b. So what's this 12 per employee? Well, we're going to write 12x, where x is the number of employees. See if we can write an equation for the second here. Well, that would be y equals, well, just 15x. Here the B is 0 because the initial payment is 0. So you don't need to put anything plus anything. Okay. Here it just says create a system of linear equations. Okay, well, we just did that. So that's your answer. Okay. Here we got a system of linear equations in the given tables. Okay. All right. Second equation minus solution. Okay. So here we need to find the equation for each of these. Well, we can write them in y equals mx plus b slope-intercept form. And hopefully you remember that the y-intercept is always 0 comma something. So whenever you see 0 comma and then a number, that number tells you the y-intercept. That's your b, that's your value of b. So in this case, for this line, our value of b is actually 0, right? 0 comma something. In this case, that something is 0. So this equation will be y equals mx plus 0. So I'm not even going to write plus 0 because plus 0 doesn't do anything. But I still need to find the slope, don't I? So in order to find the slope, you could use any 2 points you like, and you calculate the rise over run. So in this case, I'm going to just use these last 2 points because I like working with zeros. So the rise, you look at the y values. So the rise over run, our slope, we're going to do 0 minus negative 22. So again, you subtract the y values to get the rise, and then you subtract the x values to get the run. So that gives us this double negative on the 22, makes it positive. Then we have a negative 11 here, giving us that the slope is negative 2. So we know that for this first equation, it'll be y equals negative 2x. So it'll be a negative 2 here. The second equation is x minus, so they already told you the slope is 1, basically. But what's the y-intercept? Well, unfortunately for this one, they don't give you a 0 comma something. So they're not telling you the y-intercept up front. We're going to have to find it. So how do we do that? Well, y equals, and we know it's 1x, or just x, plus b, right? So the slope is 1. They already told us that, basically. Now, let's go ahead and use, here we could use any point we like and substitute the values of x and y to help us find b. I'm just going to use this last point here because they're positive numbers, and I prefer to work with positive numbers if I have the choice. So I'm going to replace y with 4 and replace x with 7. And then solve for b. So how do we solve for b in this case? Well, I would just go ahead and subtract 7 on both sides of the equation, giving us negative 3 equals b. So the second equation is x minus 3. Don't put negative 3 here. Okay, it's just x minus, they already put the minus, so just put 3. Now, how do we find the solution for this system? Well, they don't give us the solution. If you see the same thing in both lists, then that's automatically your solution. But at least here we have our 2 equations. We have y equals negative 2x. That's our first equation. And then our second equation was y equals x minus 3. Well, you could graph them and then just wherever the intersection is, that's your answer. But using substitution, we would put them equal to each other. So negative 2x equals x minus 3. And then we want to solve for x here. So the next thing I'm going to do is I'm going to subtract x on both sides of the equation, giving us negative 3x equals negative 3. Then lastly, to solve for x, we're going to divide by negative 3 on both sides of the equation. giving us the value of x is 1. I'm going to leave it to you to find the value of y, but you could substitute this in to either one of these equations to help you solve for y. Next question. An airport has 2 long-term parking lots. The cost to park y in each lot for x days is shown in the table. Okay. A system of linear equations can be used to determine on which day the cost to park is the same on both lots. One of the equations in the system is y equals 6x. I'm guessing that's this one, because it's going up by 6 each time, plus 6, plus 6, plus 6. So I can see the slope there is 6. So y equals 6x is for lot B. What is the other equation for the system? So basically, what is the equation here? Well, one thing I could do is find the slope. And the way you do that is the rise over run. So we subtract the y values on top. So we'll do 20 minus 16. If you do 16 minus 20, you'll get the same answer. Just make sure you're putting it the right way. So since I did 20 minus 16, I'll have to do 2 minus 1. Why did I choose to do it that way? Well, this will give me positive values of 4 over 1, which means the slope of this is 4. We still need to find the y-intercept, but here now I know my equation will look like y equals m, our m is 4, mx plus b. I don't know what b is yet. That's what I need to find. But I can use any point from here to help us find the value of b. So in this case, I'm just going to choose this first point, 1, 16. So if I replace 16 for y, replace 1 for x, and I want you to solve for b. Whatever value you get for b, that'll go here. And then the value of m is 4. Next question. Nora and Lila are reading the same novel for book club. Nora is on page 128 and plans to read 8 pages per day till the next club meeting. So for Nora, let's go ahead and write the equation for Nora. So it's y equals, she's reading 8 pages per day plus a starting amount of 128. So she's starting on page 128. So that's for Nora. Lila is on page 100 and plans to read 12 pages per day. So for Lila, her equation will look like y equals, how many pages is she reading per day? 12 pages a day. And how many pages is she starting at? Page 100. Okay, so that's her equation. After how many days of reading will Nora and Lila be on the same page of the book? What page will they be on? So we're going to use substitution. One thing you can do, though, is you can graph the 2 lines and see where they cross. The x value will tell you after how many days they'll be on the same page. And then the y value will tell you what page they end up on. Now, using substitution, though, we would just put these 2 equations equal to each other because they both equal y. Y equals this. So I'm going to replace the y with that. So we could write it as 8x plus 128 equals 12x plus 100. Go ahead and solve for x here. The value of x will go here. The value of y will go there. So solve for x, then substitute back in to find the value of y. Next question. A company manufactures 2 types of cabins, type 1 or cabinets, type 1 and type 2. It produces 110 total cabinets each week. Last week, the number of type 2 cabinets produced exceeded twice the number of 1-type cabinets produced by 20. If X is the number of type 1 cabinets produced and Y is the number of type 2 cabinets produced, the system of equations represents, okay, so they already gave us the system. X plus Y equals 110 and Y equals 2X plus 20, where X is the number of type 1 cabinets, and y is the number of type 2 cabinets. Okay, so whatever value you get for y, that'll go here, and whatever value you get for x will go here. Okay, now let's go ahead and use substitution. Fortunately, this one's set up pretty nicely. Notice in this second equation, it says y equals 2x plus 20. So I can take this 2x plus 20 and replace it with y right here. So substitute that in. How would that make this equation look? Well, it'll now look like x plus, what's the value of y? 2x plus 20 equals 110. We can combine these x's together. X plus 2x gives us 3x. So it's 3x plus 20 equals 110. Go ahead and finish solving for x, and that value will go here. Then once you get the value of x, plug it back into this equation, replace the x with whatever you get, and then find the value of y. Next question. Which system of equations is represented by the graph? So here we just need to find the equation for each of these. And here they already gave you the y-intercepts. This one has a y-intercept of 3. This one has a y-intercept of -3. So we can see that here. A y-intercept of 3, and this one has a y-intercept of -3. So I'm going to go ahead and help you find the equation for this one. Okay. Well, we already know the y-intercept is -3. We just need to now find the slope. The slope is your m in the y equals mx plus b. Now we know the y-intercept, the b, is -3. So I'm just going to put a -3 there for b. Now what's the slope in this case? What's our m? Well, remember, we can calculate the m, the slope, by doing rise over run. Now this line is going downwards as you go from left to right. So in this case, your slope will be negative. Notice if I go to this point, I'm going down 1 over 2. So down 1 over 2. So the slope right here will be -1/2. Okay, go ahead and find the slope of this line and put the answer there. What is the solution to this system of equations? So this one's pretty nice. It's already set up for us. X equals 12 minus y. So that means I could replace this x, or substitute this x, with 12 minus y. So let's go ahead and rewrite this second equation using that substitution. So it'll be 2 times x. Well, what's x? 12 minus y. Then we also have a plus 3y equals 29. What do I do next? Well, hopefully you see I would distribute this 2 into this parentheses, giving us 24 minus 2y plus 3y equals 29. We can combine the -2y and the plus 3y. You can combine those to give us positive 1y. We still have a plus 24 here equals 29. Go ahead and finish solving for y here. And once you get the value of y, find the value of x by replacing y in this first equation with whatever you get when solving for y here. John and Kristen are both increasing the number of minutes they jog each day as shown in the tables. All right, so for John, on day 0, he jogged for 15 minutes. On day 1, 17, day 2, so on. For Kristen, on day 0, she was running 22 minutes. Then the next day, 23 minutes, and so on. So it looks like John is increasing by 2 each day, right? So his slope would be 2x. And the starting amount is your y-intercept. Remember, your y-intercept is always 0, something. So in this case, 0, 15, it says. So for John, that's going to be his equation. I mean, instead of m for minutes, d for days, I guess. So instead of y and x, they're using days for x, so that's 2d here. And they're using m instead of y for minutes, m for minutes. So this is the equation for John's. See if you can find the equation for Kristen's. How much is she increasing by each day? That's your slope. And then what's her starting amount? That's your y-intercept. All right. Identify the system of linear equations from the table of values given below. So remember, your y-intercept is always 0, comma something. So 0, comma b. So in order to find your y-intercept, it's always 0, comma something. That tells me that for this equation, your b is 2, because you can see here, 0, comma 2. So I know our equation will look something like this for this first xy table. Y equals mx plus 2, because our b value is 2. Now, what's the slope in this case? What's the m? Well, to calculate the slope, you can do the rise over run. And you could use any 2 points you like. I'm just going to use these first 2 points. To figure out the rise, you go ahead and subtract the y values. 2 minus 0. So rise over, and then subtract the y values on bottom. Or sorry, the x values on bottom to find the run. So in this case, 0 minus -4. 2 minus 0 is, of course, 2. 0 minus -4. Well, that double negative on there, on the 4, makes that a +4. So that's going to be like that. You can reduce this fraction by a factor of 2, dividing both top and bottom by 2, giving us a slope of 1/2. So for this first table, the equation would be 1/2 x plus 2. See if you could find the equation for this second table. Next question. Joni runs the concession stand for school baseball games. At each game, the best-selling items are pretzels and hot dogs. Pretzels are $3 each, and hot dogs are $2 each. Okay, so the pretzels are going to be X, let's say, and the hot dogs are going to be Y. Today, she sold 15 more hot dogs than pretzels and made $195. So for the pretzels, she's selling them for $3 each. So $3 times the number of pretzels. Plus the hot dogs she's selling for $2 each. So what do you suppose I should write? Well, 2y. This will give you the total amount of money she brought in, the revenue. Well, in this case, it's saying the revenue was $195. So that's our first equation in the system. Our second equation comes from the fact that today she sold 15 more hot dogs than pretzels. So the way I like to think about that is, well, did the number of pretzels equal the number of hot dogs? Well, no, they're not equal, right? She sold 15 more hot dogs, right? So if I take the number of pretzels, X, and I add 15, that'll give you the number of hot dogs, right? So 15 more hot dogs. So you'd have to add 15 to the pretzels in order to equal the amount of hot dogs. From here, we would use substitution. The way I set up these equations, it's actually not too bad because here it says y equals. So that means I could take this as the value of y and replace it or substitute it in to this first equation. So now let's rewrite the first equation, giving us 3x plus 2 times the value of y, which is x plus 15, equals 195. Now what you want to do is solve for x here. What would be my first step in solving for x? Well, hopefully you would distribute this 2 here, giving us 3x plus 2x plus 30. Remember, the 2 multiplies with everything in that parentheses, equals 195. Let's go ahead and combine like terms there on the left. we can combine the 3x and 2x to give us 5x plus 30 equals 195. Go ahead and finish solving for x. Once you found x, then you'll know how many pretzels were sold, and then you can take that value and plug it in for x here to figure out the number of hot dogs. So, what is the exact solution of the system of equations shown in the graph? Okay, well, what I would want to find is I would want to find the equation for both of these lines. Let's go ahead and find the equation for this line first. This line. Okay, well, the first thing I would see is, well, my y-intercept is 7. So I know it's going to be y equals mx. I don't know the m yet, but I can see my b, my y-intercept, is 7. Similarly, for this line, it's going to be y equals mx. I don't know the m yet, but I know my y-intercept I could see is 1. So plus 1. For this equation, let's go ahead and find the slope. So what I can do is find another point that's on grid lines. I can see the point right here is on grid lines. See, I'm looking at the grid lines here. And so what's the slope? Well, I start left to right. So I go up 2 over 1. Up 2 over 1. So the slope is rise 2, run 1, which is just 2. So the slope of this line is 2. What's the slope of this one? Well, I can see it's going downward as you go from left to right. So I know it's going to be a negative. So it's going to be negative something. And I can go from this point to, let's say, this point. It's on the grid lines. I go down 3 over 1. So the rise is negative 3. So down 3 over 1. So the equation is y equals negative 3x plus 1. Using substitution, I can put them equal to each other. Because y equals this, I substitute this in for y in this equation. So that'll give us 2x plus 7 equals negative 3x plus 1. Now my goal here is to solve for x. So my next step, I think, is to add 3x to both sides. Remember, I don't like x's on both sides. So if I can move all my x's to one side, that's good. I like to do that. 5x plus 7 equals, and we have a 1 over here. What would be my next step to help me solve for x? Well, I would subtract 7 on both sides of the equation, giving me 5x equals negative 6. Lastly, to solve for x, hopefully you see I would divide by 5 on both sides of the equation, giving me x equals negative 6/5. So now I know my x value. As a mixed number, that's negative 1 and 1/5. Now, if you know me, I hate mixed numbers, but since our answer choices are a mixed number, I have to use them. So it's either B or it's D, because they both have that correct x value. We just need to figure out the y value here. So how do we do that? Well, now that I know my x value, I can take that x value. I'm just going to take the improper fraction because I don't like mixed numbers, and I'm going to replace it into one of my original equations. I'm just going to replace it into this one here. So now let's rewrite this equation, but instead of x, I'm going to write negative 6/5. So that's going to be y equals, see how it says 2 times x? That's going to be 2 times, and I'm substituting x for negative 6/5. And then plus 7. To multiply a whole number times a fraction, usually I say multiply times the top, divide by the bottom. But in this case, it doesn't divide nicely. So I would just multiply times the top and stop right there. So 2 times negative 6 is negative 12. So this is negative 12/5. We have a plus 7 here. I'll call it 7 over 1, we'll call it. This is still 7, but I'm writing it as a fraction for a reason. Now, when I want to add or subtract fractions, what do we need to have in common? Common denominator. So I'm going to have to change this second fraction by multiplying both denominator and numerator by a factor of 5, which that'll make our denominators the same. That way they'll both have a denominator of 5. You can see that here. So I'll be negative 12 fifths, y equals negative 12 fifths plus 35 fifths. What's negative 12 fifths plus 35 fifths? Well, the denominator doesn't change, so that's going to be equals. Denominator doesn't change. If I do negative 12 plus 35, well, that's going to be positive because I have more positives. But what is that going to be? 23. So 23 fifths. 23 fifths. As a mixed number, which I absolutely hate mixed numbers, but since those are our answer choices, it'll be 4 and 3 fifths. So B. Use substitution to find the solution of the system of equations. Well, one thing you can do, you can always graph these two equations and see where they cross. The intersection point is your solution. But they're asking us to use substitution, so let's go and do that. Notice it says y equals x plus 1. So I can go ahead and take this value for y and replace that with y right here. That'll give us 5x plus 7 times y. So that's x plus 1. 7 times y. And then it still says equals negative 29. What would be my next step here? Well, I would distribute this 7 into this parentheses, giving us 5x plus 7x plus 7 is negative 29. I can combine like terms there on the left. 5x plus 7x is 12x. So we have 12x plus 7 equals negative 29. Remember, we can combine these two things together because they both have the same variable, x. Now I want you to go ahead and finish up solving for x, and then you should be able to find the answer there. Heather spent a total of 70 minutes working out at the gym. She spent 20 minutes longer running on the treadmill than she spent lifting weights. Okay, so we're going to call running on the treadmill x, and we're going to call lifting weights y. Oh, actually, it says t represents the time running on the treadmill. So I guess treadmill is t, and w for lifting weights. Okay, so if we take the time she spent on the treadmill plus the amount of time she spent lifting weights, how many minutes would that be in total? Well, that's 70 minutes, right? So your first equation in this system is t plus w equals 70. Then it also says she spent 20 minutes longer running on the treadmill. So the way I kind of think about that is, does the amount of time she spent on the treadmill equal the amount of time she spent lifting weights? Well, no, they're not equal. She spent 20 minutes longer on the treadmill. So if I take the treadmill's time, that's not the same as the weightlifting time. You would have to add 20 to the weightlifting time to equal the treadmill time, wouldn't you? Okay, so there you go. What is the solution to the system x minus 3y equals negative 13 and 5x plus 7y equals 34? Again, you could always just graph them and see where they cross, but these a lot of these values are fractions, which is kind of a pain. So what we're going to do is use substitution here. So x minus 3y equals negative 13. What I can do here is I'm going to solve for x in this first equation. Now, how am I going to get x by itself? Well, I can add 3y to both sides of this equation, giving us that x is 3y minus 13. So now we know the value of x, or in other words, we can use this expression and plug it in for x, substitute it into the second equation. So this would be 5 times x. Well, what's x? 3y minus 13. And then we still have a plus 7y is 34. Now, if I want to solve for y in this case, what would I do next? Well, hopefully you see I would distribute the 5 into this parentheses, giving us 15y minus 5 times 13 is 65. We still have a plus 7y equals 34. Can we combine anything together there on the left side? Well, yes. We can combine the 15y with the 7y, giving us 22y minus 65 is 34. Add 65 to both sides of the equation. Giving us 22y is 99. I can divide both sides by 22 in order to get y by itself. So here I've got a fraction, y equals 99 over 22. I can actually reduce this fraction by a factor of 11, right? Divide both top and bottom by 11 in this case. If you can reduce a fraction, generally you want to. So the y value is 9 over 2. So now that we know the y value, you can substitute this in to right here to find the x value. So now we would rewrite this as x equals 3 times y, so 3 times 9 over 2, because that's the value of y, minus 13. So let's multiply the 3 times 9 over 2. Just multiply the 3, normally a whole number times a fraction. I say multiply times the top, divide by the bottom. But in this case, it doesn't divide nicely. So you just multiply times the top, and that's it. So 3 times 9 is 27. So this will be 27 over 2. Just keep the denominators the same. Minus 13, I'm going to call it 13 over 1. Now, when it comes to adding or subtracting fractions, thing to keep in mind is that you need the same denominator. So these denominators don't currently match. So I'm going to multiply this fraction by a factor of 2. That way, both our denominators will be 2 in this case. So 27 over 2 minus 26 over 2 gives us 1 over 2. So half. Okay, that's value that's the value of x. Okay, next question. To solve the system of equations using substitution, what could be substituted in place for y in the first equation? So I'm going to solve for y in this equation. That's what you want to do here. So we have y minus 2x equals 7. So how would I solve for y in this case? Well, hopefully you can see that I would add 2x to get y by itself. Add 2x, giving us y equals 2x plus 7. The difference of two numbers is 8. So I'm going to have two numbers, x and y, and it says their difference is 8. So when I subtract them, the result is 8. When twice the first number, so 2 times x, is added to 3 times the second number, 3y, the result is 51. Okay, so there's your system of equations. One thing you could do is just see which numbers actually work here, right? Which two numbers actually subtract to give you 8, and also 2 times the first value, 3 times the second value gives you 51. See if you can figure that out. All right, here we want to find the equation for each of these lines that are graphed here. We're going to write the lines into slope-intercept form, which is y equals mx plus b, where m is the slope, b is the y-intercept. I'm going to help you with one of them and expect you to find the equation for the other. So let's go ahead and do this one together. Here I can see my y-intercept is -1, -2, -3, -4. So my b in this case is -4. That's my y-intercept, because that's where it crosses the y-axis. Now we need to find the slope, the m. Now in this case, for this line, it's going down as you go from left to right. So that tells me the slope is negative. Now I can go from this point, the y-intercept, to another point on the grid lines. So I can see that this point right here is on the grid lines. So I can go from this y-intercept to here. Well, what's the rise and run in this case? Well, I went down 2 over 1, 2, 3, 4, 5. So down 2 over 5. So now we could write the equation y equals m x plus b minus 4. So for this equation, it's y equals -2/5 x minus 4. See if you can find the equation for this second line. Okay, last question. Carly and Angela share a cell phone plan and split the bill each month. Last month, their total bill was $109. Carly went over her data limit on her phone, so her share of the bill was $15 more than Angela's to account for the overage charge. This is back in the day when you had a certain number of minutes. Okay, which system of equations represents this situation? So if I take the Carly's bill plus Angela's bill, the total bill is 109. Okay. We also know that did Carly's amount, was that the same as Angela's amount? Well, no. Carly spent more, right? So Carly's amount was larger than Angela's amount. I would have to add $15 to Angela's amount to equal Carly's. So those are your two equations there. Okay, well, I hope that made sense. Hope you're able to get through it. And if you have any questions, leave them in the comment section below. Don't forget to like, comment, subscribe, especially if you're a returning viewer. If you're a returning viewer and I've helped you multiple times, then you can at least thank me by subscribing. Anyway, take care, guys. I'll see you. Have a good one.